it, turn it, leave it, stop, format it.
Touch it, read it, learn it, teach it, everybody talk about it. Touch it, read it, learn it, teach it, everybody talk about it. Touch it, read it, learn it, teach it, everybody talk about it. Great day, Mr. McCray, coming your way with another installment of Math Mentoring. What do we have on tap today? I'm glad you asked. Today, what we are focusing on is classwork from Market Period 1, Week 10. And that learning target is going to be, I can represent and interpret linear relationships with tables, graphs, and equations. Just a reminder, please put the closed captions on. If you're watching this video at home or watching it in the classroom, that way it can allow you to turn down the volume. All right, so let's begin. All right, for our problem today, we're going to go to full screen. Let's do it. View. Yeah, rock it out. Full screen. Yeah, okay. So we're in full screen mode. We see the learning target. Let's consider a question. So here we are. Put away some of my keys here. We got 1, 2, 3, and 4 items to consider. And we're looking for what? The ROC. What is ROC? The rate of change. What are we looking for in the rate of change? We're looking for a -3 value. Go to our first function. What do we notice? Well, it's in a table. And you have been taught when you have tables to reproduce them using the stat key. So we have a stat key here. We go to edit for number 1, and then we create our XY table based on what we see in the problem. We now hit stat again. We now hit calculator. We now hit 4 for linear regression. We now see this list that's generated for us. All right, we want to hit enter 3 times, and then we want to hit the alpha trace button, which allows us to store that value under Y1. And in storing that value under Y1, guess what we find? We find an equation. And in that equation, there's 2 parts. There's the rate of change, and then there's the y-intercept. All right, I like to have the y-intercept first, but the calculator prefers to write the rate of change first. So in this case, our rate of change is -3. Oh, no, it's 3. That doesn't help us. So we can get rid of this guy here. That doesn't help us. All right, too sad, too bad. Let's go to look at the next function. Now, the next function is not a graph, or excuse me, not a table, not a graph, but a set of ordered pairs. Same drill. Those ordered pairs, we're going to use them in our calculator by hitting the stat button. We hit edit. We generate the XY table. Go back to edit or stat. We go to calculate. We go to number 4, which is linear regression. Let me slow down so that the camera or microphone can catch up. Once we go to 4, we generate, see this table here? Hit enter once, twice, 3 times. We hit the stored value. We want to hit trace, alpha, and then trace. And then we can see we are storing this value under Y2 now. Now, so what we do is we learn that Y2 has an equation or function of -3x plus 1. All right, where 1 is the y-intercept and the rate of change is -3. Is that what we need? Oh, yeah, it is. It is what we need. All right, so that was a winner. So all the winners can go up here. All right, let's go to our next one. All right. So we've done a table, we've done a graph, a set of ordered pairs, and now we're doing a graph. So you notice how I did the graph. I just simply recreated it, and I turned it into a triangle. This is a method that I hope that at this point we feel comfortable with. So in my triangle, I had 2 points. First point was -1, 5. Second point was 2, -1. Use the calculator. The stat functions. I'm going to stop saying it because by now you should be able to go like boom, 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 and boom. And see that our function rule is negative 2x plus 3. Is it what we want? No, it isn't. Let's move it aside. Move it aside. Move it aside. Okay, got one more. Let's try it. What do we got here? A table. What does the evidence tell us? All right, we go from table to calculator to XY table to the command, alpha, and trace, and boom. We have a rule, a function rule, an equation of negative 3x plus 5. 5y-intercept, negative 3 rate of change. Is that what I'm looking for? Yes, it is. That's what I'm looking for. Okay, write it up. Functions 2 and 4 have a constant rate of change. Could this be on the test? Would this be on the test? It might. Let's keep going. All right, new question. Write an equation of the line on the grid to the right. So we have an equation that we're seeking, and we have a graph that we're giving. So what are you guys thinking might be my steps? Take about 30 seconds, pause the video, take about 30 seconds, and just see what might happen. Pause the video. Let me see if I can pull up a pause feature. I haven't done it before. Might be able to do it. That's not going to give it to me. Okay, well, it's been about 30 seconds. Let's see if you guys have anything. Compare your right answer with my right answer. All right. Boom. Use the triangle method. Got 2 points. Took those 2 points, threw them in my calculator. Now that they're in my calculator, I'm going to do a linear regression. That's number 4. From that linear regression, I find my my A, or my rate of change, is 2 over 3. My B, which is my y-intercept, is negative 2. I write them in this format right here. And I believe I have successfully answered the question. Okay? All right. I believe I've successfully answered the question for number 2. Take a minute, pause on it, look at it, write it down, whatever you need, so we can move on. And I'm going exceptionally slow because I just want to make sure you guys can actually take a minute and see what's going on. A lot of times I tell you to play and pause and rewind if necessary, but I know and you know that you don't do it. So let's take a look at the next question. Next question, all right? What, I'm down here, write a linear function. Boom, I still can use this, I like this pen. And this slows me down. All right, there we go. Write a linear function that represents the data and explain what the slope, remember I'm not going to say slope, I'm going to say rate of change, and the y-intercept mean in a given context. So that's what we're tasked to do. And I love this pointer. Here's what's going on. All right, so first of all, we take the table that's given us, plug it into our calculator. You guys remember that. Stat, edit. We only need 2 points. Okay, I can't stress that enough. On the regions, you're going to be booming, booming, booming. Tons of work, tons of problem. You want to try to streamline it if you can. Okay? We want to get to 4, which is our linear regression. We want to plug it in under y by hitting alpha trace. And my y is going to generate this function, this rule. 5.5 is my rate of change. 220 is my y-intercept. And the context of it is the rate of change in the story is $5 per 5 shirts. Remember, X was the number of shirts that was being produced, and Y was how much it cost to produce the shirts. The Y-intercept in the story is it cost $220 to set up the template for the t-shirts. So the idea is this: if we go back and looked at the XY chart or table, when we had X as 0, Y would be 220. Therefore, 220 is being used before even one shirt is being purchased. And that 220 is for the setup fee. The template is what I imagine would be a most appropriate use. All right, guys, so as we kind of transition, we're going to come back for part 2 of our video. And in part 2, we're going to be able to wrap a few things up. A couple shout outs I do need to mention. LaSarah Jones had one of the higher scores for our math lab final exam. Her, and along with 2 other individuals, I'll give them an honorable mention, Jordan Cotton, as well as Miss Tia Clements, did exceptionally well as well. Silver Sweet in that they were talking and they had a slight deduction, but I know that once we know better, we'll do better. As always, pause the video, internalize the skill. Remember, 30 minutes, study a day, keeps bad grades away.